Hello and welcome to another episode of The Improvement Man. Today's episode is a little different, as we had a request from a subscriber. Today's topic is, what is discrete and continuous data and its relationship to sample size? Let's find out a bit more. Today's upskill is about what's the difference between continuous and discrete data. We'll also be talking about sample sizes. As always, please feel free to share and reuse this video and help the community grow. And if you have any requests of your own, or would like to get in contact with me, you can reach me on helpmeimprovementman@gmail.com, or you can see my LinkedIn connection in the details below. Before we get started, just a point of clarification. This is not meant to be a replacement for sitting on a Six Sigma course or doing a math course to understand what continuous or discrete data is. I've included some links in the details below the video if you would like to know more information, and other resources I found really helpful for trying to understand this myself. So, without further ado, what is the difference between discrete and continuous data? And I've seen it written really nicely and succinctly. Discrete data is usually counted, continuous data is usually measured. And that's a quite good rule of thumb to go by. So looking more into discrete data, as I said, discrete data is usually counted. It's usually fixed values, yes or no's, good or bad's, but can be decimals, so it would go up as 1, 1.5 to 2.5. It usually follows the statement, the number of X. It's really good at gathering opinions and good for gathering qualitative data. So examples of discrete data can be, for example, the amount of people who log on to a website, or it could be the amount of interactions that a person or salesperson might have. It could also be the amount of passes or fails, or the amount of cases in law that have been won or lost. An example of the decimal is for shoe sizes. You can have a size 10 shoe, you can have a size 10.5 shoe. Unless the shoe is bespoke, you cannot go into a store and buy a shoe which is a 10.2736. Continuous data, on the other hand, is data that you would have to measure. This data can usually be a value within any range, and it's usually stated as the measurement of a thing. And continuous data, you can do more in terms of analysis with it. So generally speaking, it's more advantageous to have continuous data than discrete data. But that is not to discredit if you cannot get continuous data, discrete data, it's better to make a decision on something rather than nothing. In order to illustrate the difference between discrete and continuous data, I've provided a little example below. So, taking into account all other variables being the same, using discrete data, I'd like to choose a new law firm for my case. And so looking at the first law firm, we can see they've got 30 wins and 50 losses. Now, for all intents and purposes, when you have a sample of almost 80, you'd say, okay, you know what, that's enough to make a decision on. But then if we add another law firm in with far more points of data, i.e. they've won 167 and lost 115. So they've got a slightly better win to loss ratio. Because they've got a slightly better win to loss ratio, we're now drawn towards, well, they're slightly older, they might have a bit more experience, but we're probably going to choose firm B. But then, is that still enough of a data set to be able to make our decision? And when we throw in the complexity of firm C has an order of thousands. So they've got almost 10,000 cases to their name. And what it all boils down to is, regardless of the sample size, it's down to the decision maker to either be confident on what they're choosing or not. And this is an example of this can be seen of, should we carry out an inspection check on this aircraft? Well, how many aircraft need to fall out the sky before we decide to do something about it? And it takes into account the severity of the effect that the data has. So even the risk of one falling out of the sky is enough to prompt an investigation. The fact that one falls out the sky means that an investigation will be launched almost immediately. You don't need more data points for that part of the discrete data to make a decision. We're now going to add in the element of time. With the element of time, you can now see a very different picture. Firm A, while they have quite a good win-to-loss ratio, you can see that they perform quite consistently over the period of time. Firm C, on the other hand, that had the most amount of data points, when you start adding trend lines in, you can start seeing that it's probably not going to be the right one for us, because there's been some sort of external factor or internal factor that has led them to have a decrease in the amount of wins and losses they've had over the same period of time as the other firms. And finally, firm B looks like our initial hunch of they've got the highest win to loss ratio. When we add the aspect of time, we can see they're on the upward trend, meaning they're winning more and more cases. Actually, that confirms our and reaffirms our confidence in them, and is probably the law firm that we're going to choose. So, final thoughts on sample size and continuous data and discrete data. So, for continuous data, you can make decisions on less data points because you're seeing it against different dimensions. For discrete data, you probably need more data points to make a decision. For continuous data, the sample sizes can be smaller, and if it costs you a lot of money to do a sample, then it's probably better to use continuous data. For discrete data, conversely, you're going to need more samples to make, but it's very contextual. Continuous data has more granularity. Discrete data has more of an integer sort of thing. I was going to say binary or trinary, but it's really you're going to get good or bad, yes or no. And we see it all the time when we have how do you feel? Out of 10, are you an 8 out of 10 for happiness? You know, everyone's version of what makes happiness good or how happy they are changes. You know, what's the difference between an 8 out of 10 for happy and a 9 out of 10 for happy, unless you have some really, really strict rules on what constitutes that sort of decision. And then finally, continuous data offers more analysis options for insight, and discrete data probably has a more limited capability to learn more with the data you get. And that brings us to the end of our first subscriber request. Feedback and comments are always welcome, and you can reach me at the details below. If you'd like notifications or would like to see the latest content, please subscribe below, and hopefully I'll hear from you soon. With that, until next time.